Good morning, everyone. Welcome back to our economics class. And today we are going to discuss the continuation of the same chapter, that is the cost, production and costs. Production and costs. Okay. In this particular chapter, we already discussed about the various factors like what is the production function, what is the meaning of the term firms, and what is cost of production, revenue, profit. Okay, right? How about you people know the meaning of all these terms there. That's from the production function. We know that we discussed about a table. Okay, so various production activities we discussed with the help of a table, the relation between the inputs and outputs. So we got the equation here. Q is equal to function of labor and capital, capital. So Q is equal to F. Function of L and K. So that's a equation you have to remember today. Okay, so this is what our basic concept today. Q is equal to function of labor plus capital. Okay, or any other two inputs. Okay, here it is labor and capital. That's what Q is equal to function of L and K. Okay, so we are moving forward. So we discussed about the idea of isocant and short-run production and long-run production. Short-run production, long-run production, fixed variable, and fixed input and variable input. We will discuss that too. In the last class, we basically discussed about the total product and how to find out average product from the total product, and how to find out the marginal product and the equations related with average product and marginal product. Okay, AP for labor is equal to TP, total production for per labor, or for labor divided by labor. Marginal product is equal to change in the output and change in the divided by change in the input. Okay, so we can say that MPL is equal to delta TPL divided by delta L. Delta L. Okay, that's what the equation we'll interact with the marginal product. Marginal product. Next, we discussed about 3.4 for the law of diminishing marginal product. Diminishing marginal product. If we are adding extra product or extra input, what will happen there after a limit or after achieving the maximum? Okay, this AP and MP that going to diminish. Okay, marginal productivity will diminish or it will decrease. So that law is basically termed as the law of diminishing marginal product. Diminishing a marginal product, and we know that we used two other terms for that. Okay, law of variable proportion. Law of variable proportions. Law of variable proportions. Okay, or we can say that a law of diminishing marginal product. Law of diminishing marginal products. Okay, then we just start discussion on the shape of the curves, marginal product and average curves. Okay, so we know that it's a inverse U-shaped curve. Inverse U-shaped curve. Okay, so this is the last topic we discussed. How all these things are clear, right or not? Yes or no? Any doubts are there? Okay, don't move forward with the doubt in your mind. Okay, so just to keep all these things in your mind, to learn that properly. Doubts are there, you can ask me. Okay, now we are today. Our basic activity is to learn a new topic. It is 3.6. Returns to scale. Returns to scale. Okay, what do you mean by the term returns to scale? If you are using any input in the production, what we are expecting? So we are always expecting an output related with the input what we use. Yes or no? Yes or no? Okay, clear or not? So whatever the input we are using, always we will expect an output related with the input what we used. Okay, example in your kitchen. Okay, you have observed that few mother cooking. Okay, so they are adding all the inputs by keeping an idea in mind. What is that? If you are adding all these ingredients, we will get this result. Clear or not? Yes or no? So that many people can consume that food item. Clear? So that's a basic idea. Okay, we are adding all the ingredients to prepare a curry or any dish. Okay, so idea will be with us. What is that idea? After preparation, this much quantity of food available or that particular dish available, it can be consumed by a perfect number of people or the family members. So that idea will be there, right? So that's what always we are adding or we are keeping or we are using the inputs by keeping one thing in our mind. What is that? We want the exact or a proportionate output. Proportionate output. Clear or not? So that's what return to scale. What we are using, we are always expecting an output related with the input what we used. Okay, can you hear me? Hello?
Yes, sir.
Okay, so is that idea clear or not? So always we want to keep one thing in your mind. In this chapter, basically, it's related with the production and cost. Production and cost, right? So if you want to produce any particular product, if it is in agricultural sector or the industrial sector, okay, want to keep one thing in your mind. Without input, there is no output. Okay, so output always related with the use of input. Clear or not? Clear or not? So that basic idea should be there. Okay, so moving forward, so listen carefully. Okay, here returns to scale, the law, page number 42 in your textbook, page number 42. Okay, returns to scale, the law of variable proportions arises because factor proportions change as long as one factor is held constant and the other is increased. Okay, that we know that. Okay, in the short run production, we will make use of a number of inputs, but we'll keep change. Okay, one input we will change. Clear or not? So it will result on the production also. Okay, the output also will change as per the input what we changed, or as per the proportion of the input what we changed. Okay, so in this case we are discussing about what if both factors can change. Okay, so if both factors here, one is labor and other is capital. Okay, in short run production we told we made a change in one output, sorry, one input, right? So here give a question, what if both inputs changing? So both inputs changing means it is short run or long run?
Long run.
Both changing. Ashwarya, tell me.
Long run.
That's a simple idea, right? Okay. In the short run, always only one variable will change, one input will change. Okay. So in the long run, all the inputs will change. So keep that idea. So here we are discussing only with the example of sorry, example only two inputs are there. So here both factors are changing. So remember that this can happen only in the long term. That's what. Okay, in the long run. In the long run. Okay, so both variables are changing, or both inputs are changing. One special case in the long run occurs when both factors are increased by the same proportion or factors are scaled up. So for easy understanding, we are going to make an increment. We are going to increase both these inputs in the same proportion, same proportion. If labor increasing one, capital also will increase one, right or not? Okay. If labor we are going to increase 2 means we want to increase capital also for 2. Okay, 2 will increase. Okay, same amount will increase in both factors of production. Okay, so for easy understanding, we are not making any changes in the increment. Both will increase in the same proportion. Okay, when proportional increase in inputs results in the increase in output by the same proportion. So if you are making changes in the input, we are able to find a change in the output. Okay, that also with the same proportion. What is the proportion of change in the input that we are able to find in the output also? The production function is said to be display constant returns to scale. So keep that in your mind. It's called to be CRS, constant returns to scale. So if you are increasing one labor plus one capital, okay, so result also as per the proportion of the input, as per the proportion of the input. Okay, if you are doubling the input, the result also will double, the output also will double. Clear or not? Okay, we are doubling the input, the result also will be doubled one. Okay, or the output also will double. So that's what is constant or equal to the out sorry, input. Okay, so output is always equal to the input. Keep that in your mind. Output always equal to the input. Or if you are making changes in the next round, so what proportion? Okay, what is the proportion of change? The same proportion we are able to find in the output also. Okay, proportion of change in the input, we are able to find in the output, the same one. So that kind of a change we are able to say constant return. Okay, that kind of return is basically termed as a constant return. Okay, equal to output is equal to input. Clear? Or input is equal to output. The proportionate change we are able to find in both the input and output. That is always same. Such kind of return is called to be CRS. What is that? CRS. Constant returns to scale. Constant returns to scale. Constant returns to scale. Okay. Next one. When a proportional increase in the input result in an increase in output by larger proportion, the production function is said to be display increasing return to scale. Okay. So we are making any changes. Okay. We are increasing both the factors of production or both input we are increasing at the same proportion, clear or not? Okay, but after the production we got a result or outputs. Okay, what type of output is that? It is more than double, okay, or more than the proportion of the input what we used. That time we can say that increasing returns to scale. Okay, increasing return to scale, or it is called to be IRS, increasing return to scale. So in the first case it is what is called to be CRS, constant return to scale, constant returns to scale, where the proportion of input what we used, it will directly reflect on the proportion of the output. Okay, almost same. So it is called to be constant returns to scale. Okay, the proportion what we used. Okay, next one, IRS. What is that? Increasing returns to scale. So comparing with the proportion of the inputs, okay, we are able to get some more output or better than that. Okay, okay, more than the CRS. That time we will call it is called to be IRS, increasing returns to scale. Increasing returns to scale. Okay, so underline that whole paragraph. When proportional increase in all inputs result in an increase in output by a larger proportion. Okay, we will get extra products. The production function is said to display increasing returns to scale. It is termed as IRS, increasing returns to scale. Okay, next one, we're discussing about another one, decreasing returns to scale. Decreasing. So you know that. What is that? What is that? Can anyone tell me what is decreasing returns of scale?
Output would be less than the input.
Definitely. Output proportion of the output is less than the proportion of the input. Okay, clear or not? So easily we can understand. CRS means it is constant. Okay, the proportion is equal to the input proportion is equal to the output proportion, and IRS, increasing returns to scale, means what is that? Okay, proportion of the input is more than the proportion of the output, right? Sorry. What I told now? Okay, IRS. Okay, IRS, increasing return to scale. So proportion of the output is more than the proportion of the input, right? Yes. Okay. Now we are discussing about the DRS, decreasing returns to scale. What is decreasing returns to scale? Okay, here the proportion of the output is less than the proportion of the input. Okay, the idea is clear or not? That idea clear? Okay, so just keep that in your mind. So that is important for you people to discuss next 2-3 topics. Okay, so write down what is CRS, what is IRS, and what is a DRS, decreasing returns to scale. Okay, constant returns to scale, that is CRS. IRS, increasing returns to scale, increasing returns to scale. DRS, decreasing returns to scale. Okay, here scale means the changes of the proportion. Okay, now we can express that with an equation here. Okay, mathematical concept we will using here. So before I want to read this, decreasing return to scale, DRS, hold when a proportional increase in all inputs results in an increase in output by a smaller proportion. By a smaller proportion. Okay, outputs proportion will be lesser than the inputs proportion. That's what. For example, suppose in a production process, all inputs get doubled. So this is the thing for us here for understanding. Okay, for example, okay, suppose in a production process, all inputs get doubled as a result if the output get doubled. So we are increasing K doubled, labor doubled. So output also doubled. Clear or not? What is that? For in a production process, we doubled all the outputs. As a result, the output also get doubled. Clear or not? So that is called the constant returns to scale. Constant returns to scale. Okay, all the factors were doubled. So product output also doubled. So the production function exhibits CRS, constant return to scale. Clear? Inputs doubled, output doubled. So constant returns to scale. So if output is less than doubled, output is the less than doubled, it is called to be DRS. Clear? Output is less than doubled, so we can call it is a DRS. Okay, decreasing returns to scale. Okay, if it is more than doubled, it is IRS, increasing returns to scale. Increasing returns to scale. Clear? Okay, so this paragraph, I mean, this statement is helpful for you to understand what is CRS, what is IRS, and what is DRS. Okay, clear? Clear or not? Tell me no reply from you people. What happened?
Yes, sir.
Okay. Next one, same page, last area. I mean 42. Consider a production function. Already we know that Q is equal to function of labor and capital, or labor and capital. Okay, in the beginning we learned like that because we are using only two inputs. One is labor, other is capital. And here we are using one another method to find out it is. Okay, Q is equal to function of x1 and x2. X1 and x2. Here x1, x2 means two inputs. We don't know what it is, labor or capital. Okay, I knew two inputs, that's it. Okay, where the frame produces Q amount of output. So output is Q amount of output. Okay, by using x1 amount of factor 1. Okay, x1 amount of, okay, first input, and x2 amount of second input. X2 amount of second input, second factor. So we know that there are a number of factors of production are there. Here we are using only two factors of production, right? X1 and x2. Okay, so we can say that Q is equal to function of factor 1 and factor 2. Factor 1 and factor 2. Okay, in previous we discussed labor and capital. Here factor 1 and factor 2. Clear? Clear? Okay. Now, suppose the firm decided to increase the employment level of both the factors. Okay. So, if we are going to increase the factors of production, we will use that with a letter T. Letter T. Okay. Terms of production inputs increased. Okay. So the value of T is always greater than 1. Value of T is always greater than 1. Clear or not? So hereafter we will find T the coming equations. We will find all these equations. We are able to find this T here. So just to keep that in your mind, the value of T is greater than 1. Greater than 1 in all times. Greater than 1 only. Okay. So we are going to explain this mathematically. Okay, mathematically, we can say that the production function exhibits constant returns to scale if we have, okay, so what is that? Okay, function of, here you can see some bracket here. So are you able to see what I am writing on the board? Is that clear or not? Want to increase the size like that? No. Is it visible? Yes or no? Okay. So listen here. F function of tx1 we changed, right? And tx2. So we change the proportion. That is equal to t into function of x1 and x2. Clear or not? Same it is. What change we made in the input, the same we are able to find in the output also. Clear or not? So here T means the changes that what we made in the proportion. Clear? Okay, so function of tx1. Okay, we doubled that. Okay, just for understanding, just imagine, just doubled. Okay, doubled x1 plus doubled x2. That's what T. Value of T is always greater than 1. Greater than 1. Clear? So we doubled that. So tx1 and tx2 is equal to t multiplied by the function of x1 and x2. The same. Okay. Equal it is. Equal. Clear? Okay. So understand this. This is related with the CRS, constant returns to scale. Constant returns to scale. That is the equation for constant returns to scale. Okay. Just write down there. CRS, constant returns to scale. Okay. Constant returns to scale. Function of tx1 tx2 is equal to t into function of x1 and x2. X1 and x2. Okay. So coming to the next category, that is the new output level function of tx1 and tx2. That is the new output level, right or not? So how we changed the input, the same change we are able to find in the output. Okay. So it exactly t times the previous output level. Okay. T times the previous output level. Okay. So t multiplied by function of x1 and x2. Same. Okay. Similarly, the production function exhibits increasing return of scale. So this is equal to IRS, increasing return to scale. Okay. Here function of tx1 tx2 is more than the input what we used. Clear or not? Okay, more than the proportion of the input what we used. So function of tx1 tx2 is greater than t into function of x1 and x2. X1 and x2. Clear? Clear or not? And the confusion here. Okay. Next one, third one. It exhibits decreasing return to scale if here you can see that function of tx1 tx2 is less than what we used drs. Okay, here you can see that t multiplied by f, or I mean function of x1 and x2. Okay, so these equations want to understand thoroughly. Okay, equation for crs, equation for irs, and equation for drs. Okay. Clear. So CRS both are equal. Both are equal. Okay. Coming to IRS, function of TX1, TX2 is greater than. Okay. IRS increasing I. So keep in your mind it is greater than. Okay. It is greater than. Okay. So function of TX1, TX2 is greater than T multiplied by function of X1 and X2 IRS. Okay. Next one, less than. Sign will change into less than. That is what a DRS. Decreasing return to scale. Decreasing return to scale. So it is a DRS. DRS. Is that already clear now? Okay, tell me, any problem? Everyone, please turn on your cameras. Aditya, Anish, Anna Salim, Basil, Ashish, Grishma, Elvina, Pavitra. Okay, so if it is clear, we are moving to the next one, costs. Cost. So what do you mean cost of production? What is the idea of cost of production? What do you understood by the term cost of production? Cost of
Remuneration.
huh? Ah, okay, that is almost equal to the remuneration that what want to pay for the factors of production. Factors of production. Okay, just to keep that in your mind. So there are number of factors of productions are there, right? Okay. For understanding, I told you that 4 plus 1, 4 plus 1. Okay, land, labor, capital, organizer, and technology, what we are using to produce the product there. So for all these factors of production, we have to pay money. Okay, remuneration in terms of money. Remuneration in terms of money. That is basically termed as what? Cost of production. Cost of production. Clear or not? So just imagine if you are the owner of a company, what we will do, always try to improve the profit. Improve the profit, right or not? Yes or no? Or anyone of you have the idea to start a factory to provide service to the people? No one. Okay. If you are a private individual, we will not think about the social security or welfare or something like that. So it is always okay. We are starting industry or in industry only for profit making. Profit making. Okay. Exceptional cases are there. We are not discussing that here. Okay. So basically, we will think about profit making. Profit making. So to improve the profit, what we can do? What do we?
Minimize the cost of production.
always try to decrease the cost of production, decrease the cost of production. That's what almost all the companies, example, multinational companies, they will operate from different countries. Okay, why they are operating from the different countries? They are trying to find where this cheap factors of production is available. Okay, most of these companies will start their plants or factories in China because labor is cheap. Labor is cheap there. Okay, cheap labor availability. So cost of production can decrease. Cost of production can decrease. Clear? Next one, the same country. What is that? Availability of resources. Availability of resources. Clear or not? So that time also they can reduce the cost of production by saving the money on transportation and purchasing the resources. Purchasing the resources, right? Clear or not? Okay. Same time, almost all these multinational companies, their customer care centers will function in India. Functioning in India. Why it is so?
More educated people are here.
More educated people are there. The same time, what is that? Cheap availability of labor. Population is high, right? Okay. The proportion of the educated people also comparatively high with comparing with the other countries, right? So there and not only that, Indian youths are able to handle both American accent and English accent. Okay, clear. So most of these multinational companies will give chances to the Indian youngsters to work in this kind of what we can say, call centers. Okay, so basically this MNC is always trying to reduce their cost of production, okay, and at the same time they are functioning in these countries by keeping one thing in their mind. What is that? In these countries they are able to sell their product easily because these countries are third world countries, developing countries, the population is too high. Okay, so demand also will increase like anything, so they can sell the product easily in the markets. Okay, so various things they will keep in their mind, and they will always calculate to improve their profit. So just to keep that in your mind, you want to think about all these aspects. Clear or not? Okay, always want to reduce the cost of production to maximize the profit. Clear or not? Always want to reduce the cost of production to maximize the profit. Clear? So first of all, thinking about how can we reduce the raw material. Okay, reduce in the sense of the quality. Clear or not? Okay, or we are finding new technology to produce more products from cheaper materials. Like that, number of things are available. Clear or not? Okay, so almost all the producers will think about how to reduce the cost of production to maximize their profit. So we are going to discussing about costs here. Costs. Okay, the money that what we are spending to produce a new product. Okay, not only industries, agriculturalists also will do the same. Okay, farmers also will do the same. Example, for farmers, how can they improve the production? Anyway, the area of land is not going to increase. If you have 1 acre of land, this year 1 acre of land, that year also 1 acre of land only. Okay, the area of land, geographical area, that not going to increase. So how can we improve the production from your given or a specified area? How can we
Use
improve?
of HIV seeds,
Definitely.
fertilizers.
Definitely, yeah. Number of methods are there. Okay, so instead of cultivating for 2 seasons, you can cultivate for 4 seasons, right or not? If you are using high yielding variety of seeds, instead of cultivating for 2 seasons, we can cultivate for 4 seasons. Okay, clear or not? High yielding variety of seeds. Okay, the regular seeds it will take 4 to 6 months. Okay, to get the result, but the high yielding variety of seeds 3 to 4 months, right? So we can increase to 3 or 4 cultivable seasons. Not only that, we can increase the production by using pesticides, insecticides, chemical fertilizers, good irrigation facilities, right or not? Okay, so we can improve. So agriculturalists always will thinking to reduce the cost of production by using a new technology. Clear? So new technology, since we know that today combined harvesters are there, right? Okay, tractors are there, tillers are there. If you are employing people or human labor, it will take much time and it is costly. Okay, so farmers are giving preference to this kind of machines today, so they can reduce the cost of production. So just a thing. So production means, don't think only the industrial production, but agricultural production also coming under production only. In order to produce output, okay, we are here 3.7. In order to produce output, the firms need to employ inputs. Okay, that we know. Everyone know that. Adul, what happened? Any doubt?
No, sir.
Okay, so in order to produce output, the firms need to employ inputs. Definitely, we know that. So without input, there is no output. But a given level of output typically can be produced in many ways. So in the so if we are not going to make any changes in the output, we are able to choose different combinations. Okay, yes or no? Different combinations we can choose. So that we already we had seen here. So in this table, 3.1 production function, right? So there are number of different types of combinations are available to produce 10 units, right? Right or not? That is up to the producer. For example, for 50 also, different combinations are available. Different combinations are available. Okay, clear? So 40. For 40 also, different combinations are available. Okay, so like that, with the available inputs, we are able to choose the combinations. And here it is. Typically can be produced in many ways. There can be more than one input combinations with which FM can produce a desired level of output. Okay, so there can be more than one input combination. Okay, many combinations are there. Okay, more than one input combination with which the frame can produce a desired level of output. In table number 3.1, we can see that 50 units of output can be produced by three different input combinations. What are that input combinations? L6K3, L4K4, L3K6, L3K6. Okay, we already observed that. We already learned that. The question is which input combination will the firm choose? Okay, here comes the question. Okay, in this, which combination is most profitable one? Okay, so always the producers will move to choose that, or they will choose that particular combination. With the input prices given, it will choose that combination of input which is least expensive. So always the producers will choose the inputs which is least expensive. Clear or not? So number of combinations are available, but the producer will choose the combination which with the least expense or least money or least value. Okay, so for every level of output, the firm chooses the least cost input combination. So underline that area. So for every level of output, the firm chooses the least cost input combination. Least cost input combination. Least cost input combination. Okay. Thus, the cost function describes the least cost of producing each level of output given prices of factors of production and technology. So we can say that the cost function describe the least cost of producing each level of output get given prices of factors of production and technology. Okay, so hereafter whatever the input we are choosing, that describes the least cost combination. Okay, always the producers will choose that only. Clear? Yes or no? Hereafter, whatever the combination that is termed as a least cost inputs or least cost combinations. Okay, so you can see here Cobb-Douglas production function. So economist. Okay, so consider the production function Q is equal to x1 alpha and x into x2 beta. You can see here Q is equal to x1 alpha, x2 beta. Okay, here alpha and beta are constant. The proportion, they are constant. Clear or not? The proportion is constant, not changing. The first situation. Okay. The firm produces Q amount of output. Okay, the firm producing Q amount of output. By using x1 amount of factor 1, and x2 amount of factor 2, alpha and beta. This is called a Cobb-Douglas production. Okay, so this method is basically called as a Cobb-Douglas production. Okay, suppose with x1 is equal to x bar 1. Okay, x1 bar. Here bar means there is no relation with the proportion. Clear or not? Okay, so x1 is equal to x1 bar and x2 is equal to x2 bar, x2 bar. Clear? Clear or not? So for understanding, x1 is equal to x1 bar. We already know that alpha and beta are a constant. There is no change. There is no change. Okay. So x1 and x1 is equal to x1 bar and x2 is equal to x2 bar. X2 bar. So we have QO, I mean Q0 units of output. Q0 units of output. So we rewrite the equation like this. What is that? QO is equal to x1 bar alpha multiplied by x2 bar beta. X2 bar beta. Okay. The idea clear or not? So directly we are making a change here. Okay. So we are rewriting the equation like this. What is that? Q2 QO that is equal to, okay, already we know that. Suppose x1 is equal to x1 bar and x2 is equal to x2 bar, the equation will change into, okay, Q0. Okay, Q0 quantity. If you want to produce Q0 quantity, we want to use x1 bar alpha and x2 bar beta factors. Okay, or inputs inputs. If we increase both the inputs t, okay, t we know that it's greater than greater than one time. Use this equation related with the CRS, IRS and DRS and the DRS. We know that t is greater than 1. Okay, t is greater than 1. Okay, 1 times we get the new output. So we increase the inputs in t times, so new inputs formed here, new inputs formed, and as a relation with that new output also. So q1 new input for we people, q1 is equal to, what is that, t x1 bar alpha multiply with t x2 bar alpha, sorry, beta, x2 bar beta. So equation change here, you can see here. So t times we changed it. T times we changed it. Okay, from Q0 to Q1. Okay, Q1 quantity. Clear or not? So t times we changed it. That T1 is greater than 1. We know that. So we kept here 1 here, right? So t x1 bar alpha raised to alpha multiplied by t x2 bar beta. X2 bar beta. Okay, t x2 bar all raised to beta. All right. Okay. So the equation is Q1 is equal to t raised to alpha plus beta multiplied by x1 bar alpha multiplied by x2 bar beta. X2 bar beta. So easy to calculate, easy to find out that. What is that? Alpha plus beta is equal to 1. If it is 1, what is that? Constant or not? Yes or no? If it is 1, it is constant or not? That is ERS, right? Okay, that time we will get a Q1 is equal to times of a Q0. Okay, how many times we changed it? That many. Okay, Q0. That is, the output increases T times. So the production function exhibits CRS, constant rate of a scale, constant returns to scale. Constant returns to scale. Similarly, when alpha plus beta is greater than 1, so same application here, same application only. Okay, okay, alpha plus beta is greater than 1. That time we can say that production function exhibits IRS. IRS. What is that? Increasing returns to scale. Increasing returns to scale. Increasing returns to scale. Okay. When alpha plus beta is less than 1, that time we can say it is a DRS. Okay. Decreasing returns to scale. Decreasing returns to scale. Okay. That idea clear? Clear? Okay. So almost all the teachers, they give a particular time for you people to complete the projects, right? Yes or no? Okay, so we are fixing to complete our project. That particular day is there for us. That is 28th of this month. 28th of this month. All right. Clear or not? Don't think that a long period of time is there with you. Okay, I already provided topics for you people. The working one. I mean, you want to write the rough. Okay, rough with 2-3 pages. Okay, maximum 5 pages. Write that, Aishwarya. 5 pages only, no. So 5 pages. Write the rough and submit me. If any corrections required, I will inform you. Okay. Clear? So within 2 days, you have to complete that task and start writing the fair copy. Okay, everyone. Thank you very much. We will meet in the next class. Before that, I want to say something. Read the textbook thoroughly and understand the ideas properly. Clear? Okay. Okay, guys. Bye.